Today we are going to discuss characteristics of Fermi surface. So, the Fermi surface, what does it represent? Actually, it represents the dynamic and inertial properties of conduction electrons. Okay, Miss, it can easily tell us about the electrons. Now, the volume of Fermi surface, suppose we are having this Fermi surface, and its volume will represent the number of conduction electrons can be easily represented by the volume. Okay, at absolute zero, when the system is in ground state, suppose we are having a system which is in ground state at absolute zero, and no quasi-particles are excited in it, then there will be a boundary between the momentum state that are occupied and those that are vacant. So the boundary between the vacant and the occupied states, or we can say the boundary means outermost member of a set of nested surface. Actually its structure is like nested surface, one surface inside the other, and we can easily say it like a Spanish onion. It is compared with a Spanish onion. Okay, and this surface is known as the Fermi surface. So, for a system of free electron where all momentum states are equally probable, then the surface will be a sphere. Okay, so shape of Fermi surface is determined by the geometry. Whose geometry? Geometry of the energy contours which will be available in the band. Since Fermi surface is itself an energy contour. Okay, now Fermi surface can be complicated or distorted shape or quaint shape. It can be modeled, and so it will easily provide us many information. Okay, it can be easily modeled. Now, for if we are considering a spherical Fermi surface, suppose the Fermi surface is spherical, then the momentum and velocity vectors are always collinear. Hence, the effective mass m star or m asterisk will be a scalar quantity. And for non-spherical shapes, where p and v, they will be parallel. Okay. For non-spherical Fermi surface, P and V will be parallel. Then next characteristic is Fermi surface can easily intersect the zone boundary perpendicularly. Suppose we are having different zones, and it will easily intersect with the zone boundary, but it will intersect with the zone boundary perpendicularly. Okay, and this indicates that the conditions are correct for the Bragg reflection to occur. Then comes all the phenomena in which we are usually interested affect only the electrons that may be thermally excited. Okay, that is lie in an energy range of the order of kT in width about the Fermi level. So knowledge of band structure near Fermi level is required sometimes, and Fermi surface tells us also about the properties, various properties like heat capacity, then Pauli's paramagnetism, or properties arising from different electrons' motion like conductivity. So there are many concepts which can easily be understood if we can guess the Fermi surface. But Fermi surface cannot tell us about the symmetry of the wave function of electrons. The electronic properties of metal can be easily determined by the shape of Fermi surface. Okay, so there are many characteristics of Fermi surface, and looking at the Fermi surface, we can easily tell us many important properties related to a crystal structure. Thank you.